In this video, we are going to be discussing what we call the temperature converting what now scale. Okay, now we have four types of temperature what now conversion scales. We have the Kelvin scale, we have the Celsius scale, we have the Fahrenheit scale, and we have the Rankine scale. Okay, are you with me, class? Now, before we are going to do justice to all these four what now temperature conversion scales, there are some three concepts that we must understand. These are the lower fixed point, the upper fixed point, and the fundamental what now interval. Class, are you with me? These are the four scales that we have. What is the lower fixed point? Each of these scales have what we call lower fixed point, and each of these scales have what we call the upper fixed point. To this Kelvin scale, 273 is the lower fixed point. I use LFP to denote lower fixed what now point. So to this Kelvin scale, the lower fixed point is 273. To this Celsius scale, the lower fixed point is 0. To this Fahrenheit scale, the lower fixed point is 2. And to this Rankine scale, the lower fixed point is what now? 492. What about the upper fixed point? The upper fixed point to a Kelvin scale is 373. Upper fixed point to a Celsius scale is 100. The upper fixed point to a Fahrenheit scale is what? 212. Then the upper fixed point to a Rankine scale is 672. Class, all these scales are very key. Okay, you must memorize all these numbers that I have what now discussed here, because they are the major factor, the key concept as far as calculation under temperature conversion scales what is concerned. Now look at this. This lower fixed point can also be called the ice point. So in some question, we will not see lower fixed point, but we will see ice point. Once you see ice point is also the what now? The lower fixed what now point. Then for upper fixed point, you will see steam point. So we're saying steam point is the same as the what now? The upper fixed what now point. What's now Fi? Fi means fundamental what now interval. Class, the difference between the lower fixed point and the upper fixed point is what we call the fundamental what now interval. So we are saying for Fi, we have upper fixed point minus lower fixed point. That will give us the fundamental what now interval. So once we understand these three key concepts, we can do analysis and justice to these skills. Are you with me? So let's go now. Here, the formula that we're going to be using is what we call similarity what now property. We compare and contrast. Okay, this what now, these four skills. Look at this. For this first one, we have K minus lower fixed point. So to this Kelvin scale, we have what now? K, okay, minus what is the lower fixed point? 273 all over what is the fundamental interval? That is what now? 373 minus 273, and that will give us what now? 100. Class, are you with me? So let's go for this one. We'll have what now? The what now? Celsius minus what is the lower fixed point? That is what now? 0 all over what is the fundamental interval? That is 100 as what now? 0, and that will give us what? 100. Class, are you with me? Then the third one, we have degree what now? Fahrenheit minus what is the lower fixed point? That is what now? 32. Okay, all over what is the fundamental interval? That is 212 minus what now? 32, and that will give us what now? 180 equals. For the Rankine scale, we have what now? R minus what is the lower fixed point? That is what now? 492 all over what is the fundamental interval? That is 672 minus 492. That will give us what now? 180 degrees. Okay, when you check this analysis very well, we're going to be using what now? This formula. Okay, we can relate any two of the formula at a time. I can either relate this and this, okay, or I can relate this with this, this with this. I can't relate the four at a time. I can only pick two of this formula to relate, okay, and to solve question at a time. when you check this what now analysis, you will see critically that what now the fundamental interval of the Kelvin scale and the Celsius scale are the same. Are you with me? While the fundamental interval for the Fahrenheit scale and the Rankine scale are what now the same. Class, let us now see how we can use this to solve what now question. You don't do what now to fidget. Whenever you see question under what now temperature conversion scales, use this formula. Okay, are you with me in class? Can I continue? Now look at this. Let's solve some questions. We have two questions to be solved here. We have to convert 50 Fahrenheit to Celsius what now scale. Permit me to wipe this place up. Are you with me in class? So we are asked to convert what now? First question, 50 Fahrenheit, 50 what now Fahrenheit to Celsius what now scale. And second question, we are asked to convert 18 Celsius, 18 what now Celsius to Fahrenheit scale, Okay, so meaning now the question you ask yourself whenever you see question like this is, what are the two scales that are involved in the question? If you check the first one here, we have Fahrenheit and what now and Celsius. Okay, if you check the second question too, we have what now Celsius and what now and Fahrenheit. So it means I'm going to be relating what now Celsius and Fahrenheit scales together. Are you with me in class? So we wrap this one up. Okay, now so let's go. The first question A of the question, we are have to convert what now 50 what now Fahrenheit to what now to Celsius. Okay, we draw the two what now scale involved. So we are having what now Fahrenheit scale and having what now Celsius what now Celsius scale. Are you with me in class? Like I told you, you must know by heart the lower and the upper fixed point of these scales. So for the Fahrenheit scale, our F is here. For the Celsius scale, we use our what our C. Now, what is the lower fixed point of a Fahrenheit scale? That is what now 32. Look at the way I want to solve the question. Okay, what is the upper fixed point of a Fahrenheit scale? That is what now 212. So here I have what now 2 1 what now 2. Okay, now we are given 50 what now 50 Fahrenheit. So after the 2 we must see 50. Are you with me? After the 2 we must see 50. Okay, so here I can put what now 50 what now degrees here. Okay, Fahrenheit. Now for the second scale, the lower fixed point is what now is 0. The upper fixed point is what now 100. Any question given, I have to label the lower fixed point and the upper fixed point first because they are what now they are constant. Are you with me? Then I'm now have to find what now my C. Okay, this is the C that I'm looking for. Okay, meaning what will this 50 Fahrenheit on the Fahrenheit scale correlate or correspond to on the what now Celsius what now scale. So we use what now similarity what now property. Are you with me? So let's go. So we go using this what now concept. F which is what now 50. So we have what now our F minus the lower fixed point. Okay, lower fixed point all over what now fundamental what now interval. Okay, for the what now Fahrenheit scale equals to what now our C minus the lower fixed point. Are you with me? All over what now fundamental what now interval. So what's our F? Our F here is given as what now as 50. Are you with me class? Minus what is the lower fixed point? That is what now 32. Okay, all over what is the fundamental interval? That is 212 minus what now 32, and that will give us what 180 what now degrees equals the C that we're looking for. Okay, minus what is the lower fixed point is 0 all over what is the fundamental interval? That is 100 minus what now is 0, and that will give us what now 100. So what's the next thing? We can cross multiply. Are you with me class? We will cross multiply. So here we're having what now 50 minus what now minus 32. We have to be very careful, okay, so I will not make mistake. So 50 minus 32 will give us what now 18. So here I'm having 18 all over what now 180 equals C minus 0 is what is C all over what now 100. So let us cross multiply. This one will come here, this one will go here. So we're having what now C times 180, that is what now 180 what C equals 18 times 100, that is 180 what now 0. So it means our C will be equal to what 1800 all over what now 18 what now 0. This will cancel out this 18 here what 1, 18 here what now 10. So it means our C will be equal to what now a 10 degree what now Celsius. So here our C will be equal to what now 10 degree what now Celsius. So it means the 50 Fahrenheit what now scale on this Fahrenheit scale correlates to 10 degrees Celsius on the Celsius what now scale. Are you with me, class? Now let's solve question number 2. We want to convert what now 18 degree what now Celsius to Fahrenheit. We are still comparing these two what now, these two scales. So but we relabel. Let us relabel. So from here, let me wipe this one off. Are you with me? So let me wipe this one off. So now second question. So here we relabel. This one is constant. This one is constant. This one will change. Okay. We're given what now? 18 degrees Celsius. So it means this one is given. 18 degrees Celsius is given. This is what now? 18. We're not looking for what our F. Do you see that now? So anytime we're given what now? Temperature conversion scale. We'll draw the scale involved and we'll label them. The first thing, we must label the upper phase point and the lower what now? Phase point. Are you with me? So from here, we are given 18 and we have to find this. I'm still using these two formula. Okay, fundamental what now? Interval. So let's go here. What our F in this case? Our F is what now? The unknown. So I have what? F minus what now? What is the lower phase point? That is what? 2 all over. What's our fundamental interval? That is 212 minus 32. And that will give us what now? 180. All over. Our C is given as what now? 18. Are you with me? Minus. What is the lower phase point? Is 0. All over. What is the fundamental interval? That is 100 minus what now? Is 0. And that will give us what now? 100. So we'll multiply. We'll now be having what now? F minus what here? 32 all over what now? 180 equals 18 minus 0 is what now? 18 all over what now? 100. So we can multiply now. Is that not? So let's multiply. We're having what now? 100. Open bracket what now? F minus what now? 2 equals to what now? 180 times what now? 18. So let us multiply. 100 times this will give us what now? 100 what? F minus 100 times 2 give us what now? 3200. Are you with me? Equals to what now? 180. 180 multiplied by 18. That will give us what now? 324 what? 0. We correct that time. So we're having 100F equals to what now? 3240 plus 3200. So our 100F will be equals to, okay, that will be equals to what now? 3240 plus 3200. So we're having what now? 6440. So let's confirm. 0, 4, 4, and 6. So it means our what now? Our F will be equals to what now? 6440 all over what now? 100. So here we have what? 6440 divided by what? 100. And that will give us what now? 64.4 degree what now? Fahrenheit. So it means our 18 degree what now? Celsius is equals to what now? 4.4 degree what now? Fahrenheit. Class, if you've enjoyed this lecture, I want to give another what now video. Okay, how to use this same concept. Okay, under thermo what now? Metric what now? Liquids, or what we call thermometric what now? Conversion. Talking about what now? Our what now? Mercury what now? Mercury thermometer. Talking about what now? Gas thermometer. Talking about that what now? Our resistance what now? Thermometer. We can use the same concept to solve. So in the next video, that is what I'll be doing. I'll put the link of that video below this video. Make sure you watch the video, okay? Because you enjoy more. Okay, once you understand this concept, I'm going to use this concept to solve question on the part 2 of this. Let me put it like that, part 2 of this video. If you've enjoyed this video, okay, class, you are going to do me a favor. Okay, like the video, share the video, okay, comment in the comment box below, and don't forget to subscribe to my YouTube channel. Thank you very much for watching.